So now we're going to take a look at our fourth quadric surface, the elliptic circular cone. The main thing here that I want you to pay attention to is the fact that the equation is equal to 0 when you put everything on the left-hand side. So that's important. That's what distinguishes this from the previous three quadric surfaces that we looked at. So with an ellipsoid or a sphere, we saw that all three variables were squared, and when you put them on one side, and then equal to 1. If we look at hyperboloids, so let's actually just look real quick. Hyperboloids have a negative sign when it's equal to 1, so one of the variables is negative. When it's a 1 sheet, and when it's 2 sheets, there's 2 negatives, but it's still all equal to 1. Now there is one variable that has a different sign from the other two, but when you solve it, it's equal to 0. This is going to end up being a cone. The variable with the different sign when you set it equal to 0 is going to be your axis. The reason I'm calling it a different sign and not just focusing on it being the negative variable, for example, is because when this equation is equal to 0, I could technically multiply through by a negative on that whole equation, and then I would have negative x squared, a negative y squared, and a positive z squared. So depending upon how you solve it, there isn't a right way to do it. The whole point is that there's supposed to be two variables that have one side, and a third variable has to have the opposite sign. When we go and we look at traces, in the xy plane, we're again setting z equal to 0. And when I do that, this term disappears. And my equation that I'm left with is just the sum of two squares being equal to 0. Now, in general, x squared over a squared plus y squared over b squared can only be greater than or equal to 0 because it is the sum of non-negative terms. So the only way it's going to be equal to 0 itself is if x and y themselves are 0. And so this corresponds to, on my picture, it corresponds to the origin, because I know that z is equal to 0 since I'm in the xy plane, and then the only way to solve this equation equal to 0 is for x and y themselves to be 0. I could shift, just like I did in the hyperboloid of 2 sheets situation, I could shift z up or down. I just chose z equals plus or minus c because that this simplifies nicely. If I plug in plus or minus c, this value becomes 1. When I rearrange it, I end up with the standard equation of ellipse. So that tells me that when you move up, you're going to get ellipses. When you move down, you're also going to get ellipses. In the YZ plane, when I set x equal to 0, I get this difference of squares. Now, we've seen what happens when that difference of squares is equal to 1, and you get hyperbolas. But when it's equal to 0, you can take the z squared term to the other side and take the square root of both sides and rearrange. And when you're done rearranging, you get that z is equal to plus or minus a constant times y. Let's pretend that constant was 1 when we simplified. Then we would get z equals plus or minus y. That corresponds to what are intersecting lines that are going through the origin in the YZ plane. So that's what these pink lines correspond to. If I do the same thing in if I do the XZ plane, I'm going to get the same type of thing, except this time I'm going to remove y. And when I go to solve, I'm going to get z equals plus or minus some sloped line, slope times x here. And those are those green lines. Notice that these are intersecting lines through the origin, and they are positioned in the XZ plane. So that's what creates the cone. But the main features you want to pay attention to when you're identifying this: put everything on the left-hand side. If there is no constant left and it's equal to 0, and you have a negative sign, or at least one negative sign, then you know it's going to be an elliptic circular cone. Now, if you put everything on one side and all the variables have the same sign, then the only way you get a solution there is to have a single point at the origin. That's kind of like talking about a sphere of radius 0 centered at the origin. But anyway, defining feature, all are squared, all on one side, equal to 0. The term that has a different sign than the other two will be the axis that you draw the cone on.